and then welcome to a brand new video. This is Half Beyond Numbers, where we learn maths the easy way. Now, in this video, we'll be looking at how to compare another fraction. First of all, when we want to order fraction, or when we say ordering of fraction, what do we mean? So ordering of fractions simply means you are arranging the fractions in ascending order or descending order. When we talk of ascending order, it simply means from the smallest to the biggest. And when we talk of descending order, we mean from the biggest to the smallest. Let's write down some notes. So ordering of fraction involves arranging fractions in ascending or what? Descending order. And when we say ascending order, we mean from the small or from the smallest to the biggest. And then when we say descending order, we mean from the biggest to the smallest. Okay, so now that we know what ordering fractions are and then what ascending and then descending order is, let's look at what we use to what order these fractions. There are some symbols we use to order these fractions. The first one, which we all know, I think, is the greater than symbol. This here is called the greater than. And what this simply means is, if I say A is greater than B, then it means the value of A is more than the value of B. So for instance, if I take these numbers, such as 5, and I say it is greater than what? 2. As you all know, if you have 5 mangoes, you will definitely have more mangoes than someone who has what? 2 mangoes. We are using this greater than symbol to illustrate the greater portion of the 2. Now there is another symbol that we are going to be employing here, which is called the less than symbol. So for this less than, it is the opposite of greater than. Hence, if I say A is less than B, then all I'm trying to say is that the value of A is smaller as compared to the value of B. As we can see in the example of 2 being less than what? 5. So these are the symbols we'll be looking at when we want to order fractions. Now let's look at the methods we would also employ to order fractions. There are 2 methods, actually 3, but then we'll just be looking at 2 of them. The first one is the common denominator method. The next one is the decimal conversion method. And the very last one is the number line method. But we'll just limit ourselves to the common denominator method and then the decimal method. So these are the 2 methods we will be looking at in this video. Okay, so using the common denominator method, that all it seeks to do is to what? Make sure both fractions we are using have a common denominator, just as the name suggests. All right, so take note of that. We are going to solve some questions so we see and then understand how we have to arrange 2 over 5, 1 over 4, and 3 over 10 in ascending order. And earlier on, we said ascending order simply means what? From the smallest to the biggest. Let's see how we are going to go about that. So we have 2 over 5, we have a 1 on 4, and then 3/10. If you want to use the common denominator method, the first thing you need to do is to look for the LCM of 5, 4, and then 10. So if we take 5, for this first one, we'll write them out and then get the LCM, after which our subsequent examples, I would assume you already know how to look for LCM so that we can proceed. So for 5, we look for the multiples of 5. We have 5, then we have what? 10, we have 15, there is a 20, 25, and it goes on and on and on. Then for 4, we have 4 itself. There is a 16, there is an 8, a 12, 16, 20, 24, and goes on and on and on. Then for our very last one, which is 10, we want its multiples. So there is a 10, there is what we call a 20, there is a 30, and it also goes on and on and on. Now, among all these multiples, you would want to write the smallest one that is common to all of them. Or first of all, you would want to write out the common ones among them all. So if you look at it carefully, it simply means our common one is going to be what we have here as what? 20. 20 is common to what? All of these multiples. 5 is not common to all. 10 is not common to all. It is just common to 5 and 10. But we want one that is common to all. So if there are more than one that are common, then what you are going to do is you would pick the lowest one. But up to this stage here, we have just one that is common to them all. And that is what? Our 20. Hence, what we are going to do is we write down all these fractions and their equivalents, but with a denominator of what we have here. This the 20. What I mean is we would have to write 2 over 5 equivalent, which has a denominator of what? 20. So if you are to take them one after the other, then taking 2 over 5. Taking 2 over 5, it is going to be what? Equivalent to, we want something that is what? Over 20. Now 5 times what gives us a 20? We know 5 times 4 is what gives us a 20. We would therefore multiply the 2 also by the 4. So that we're going to get 2 times 4, which is what? 8. So we have 8 over 20. So we have written another equivalent form of what? 2 over 5. Then we go to the next one. The next one is 1 over 4. Now for 1 over 4, it's equivalent with a denominator of what? 20. So over 20. And we know that 4 multiplies 5 to give us the 20. Hence, we would have to multiply the numerator also by that 5. So that is 1 times 5. And that gives us a what? A 5 on 20. Then our very last one here is 3 over 10. So for 3 over 10, you can pause the video at this point and then try getting or figuring it out yourself. Yes, so if you're able to figure it out, then that is good. Now we are writing our denominator as what? 20. And then we ask ourselves, 10 times what gives us the 20 we have over here? So 10 times 2. Hence, we will have to multiply this numerator as well by 2. That is 3 times 2. And 3 times 2 gives us a 6. So we have 6 over 20. So on that note, this should tell us that the fractions we are going to use are what we have over here. These fractions are what we are going to use to determine or to arrange, to do our arrangement. Let me introduce you to what we call like fractions. Like fractions are just fractions with what? The same denominator. You see? And as we can see here, these fractions have the same denominator. This is over 20, this is over 20, and this here is also over 20. So we say they are like fractions. They look alike. Now, one fascinating thing about like fractions is that you can easily compare them with their numerators. So for this fraction we have over here, if we would want to compare them, then we can say that 5 over 20 is the smallest. You see, 5 over 20 is the smallest. This implies that 5 over 20 is the smallest. And we know 5 over 20 corresponds to 1 over 4. So 1 over 4 is less than. The next fraction we have is what? So the next one after 5 is 6. And 6 over 20 corresponds to 3 over 10. So 1 over 4 is less than 3 over 10, which is also less than. the last one, which is what? 8 over 20, whose fraction is 2 over 5. All right. So what have we done? In this first example here, we have illustrated how to compare fractions using the common denominator method. Using the common denominator method, you just have to make sure, first of all, that all the fractions have been written in what? One denominator. You see? Now, after writing all of them that way, just compare the numerators, and you are good to go. So this was quite long because it's the first one, and I wanted to explain the concept. But now, let's go straight forward to it, as you have understood the basic concepts. So let's take another example. So for this second question here as well, we are to arrange 1 over 3, 1 over 2, 2 over 5, and then 1 over 4 in ascending order. So take note of what the order in which you are to arrange them in ascending order. So once again, we take out our fractions. And what are our fractions? We have 1 over 3, 1 over 2, 2 over 5, and then 1 on 4. Then you look for the LCM. So you want the LCM of 3, 2, 5, and 4. What number can all these numbers divide successfully? So just as we did in our previous examples, you look for their multiples. So multiples of 3, then come and look for that of 2, 5, and then 4. You would find out that the LCM is 60. That is a number they can all divide through. So if the LCM is 60, 3 divides 60 how many times? 3 divides 60 how many times? 20 times. So if their LCM is 60, and then we are saying 3 divides 60 20 times. So we are going to have 1 over 3 giving us what? 1 times the 20 over 3 times 20. And if you multiply 1 by 20, what do we get? We have a 20. And then 3 times 20 also gives us what? 60. Then we come to the next fraction, which is 1 over 2. We start the same method. So 2 divides 60 how many times? 3 times. Sorry, 30 times. So it means we are going to multiply 2 by 30. So let's multiply 2 by 30. And let's also multiply 1 by 30. And that is going to give us a 30 over 60. Then the next one, we have 2 over 5. So for 2 over 5, once again, our LCM, which is 60, we are going to divide 60 by 5. 5 divides 60, 12. So we have 12 times. So we are going to multiply 5 by the 12 and also multiply 2 also by the 12. And 2 times 12 we know gives us what? A 24. 5 times 12 we know on the other hand gives us what? 60. Then the very last one. So for the last one, we have 4. And 4 divides 60 how many times? 15 times. So we are going to multiply 4 by 15. You see? And then we also multiply 1 also by 15. So 1 times 15 gives us a 15. And then 4 times 15 also gives us 60. With that done, we now have the equivalent form of all the fractions specifically written over 50. So all we need to do now is to arrange the numerators. And since the question says in ascending order, then we are going to look for the smallest to the what? Biggest. From the smallest to the biggest. So for our smallest, we are going to start with what? 15. As you can see, 15 is the smallest among all of this. 15 over 60 corresponds to 1 over 4. So it means 1 over 4 is the smallest. It is less than, followed by what? 20 over 60. And 20 over 60 represented 1 over 3. Followed by the next one on our list is 24. And 24 is represented by 2 over 5. 2 over 5. Then our very last one, which in itself is 1 over 2. So these are our fractions arranged in ascending order. As you have seen us do, we first change them into what? Equivalent forms, all of the same denominator. After which, we then arrange what? The numerators. I hope that makes sense. So let's look at another example, which will probably be our last. And then I'll give out some questions for trials. So this example here says we should arrange 3 over 4, 1 over 3, and then 3 over 5 in descending order of magnitude. Take note, it is in descending. Descending here means from the biggest to the smallest. So how do we go about this? As usual, let's put down our solution. And our fractions, which are 3 over 4. If you look at the denominators, we have 4, 3, and 6. 4, 3, and 6. If you are looking for the LCM, the number that both 4, 3, and 6, or all of these numbers can divide, is what we call 60. If their LCM is 60, let's take note of that 60. Then we ask ourselves, 4 divides 60, how many times? 4 divides 60, how many times? That is 15. So what we do is we write the equivalent form of 3 over 4 with respect to 60. What I mean is we have 3 times 15. We are multiplying both the numerator and then the denominator by this 15. And 3 times 15 we know gives us a 45 over 4 times 15, which gives us a 60. Then we'll go to the next fraction, 1 over 3. Remember, our LCM is 60. So this time around, we divide again by what? 3. 60 divided by 3 gives us a 20. So you multiply both the numerator by this 20 and the denominator also by the 20. 1 times 20 gives us a 20. And 3 times 20 gives us a 60. Then for the very last one, 3 over 5 is equal to, so 5 divides 60 as well. How many times? That is 12. So we multiply the numerator by the 12 and the denominator also by the 12. And that gives us 3 times 12, we have 36 over 5 times 12, we have 60. So with this done, we now have what? 45, 20, and then 36. And they are all over 60. So to rank them in descending order, we are going to write the biggest one first. And 45, 20, and 36, the biggest is 45. 45 over 60 corresponds to what? 3 over 4. So we have 3 over 4 being our greatest. So it is greater than the next one, which is what? 36 over 60. 36 over 60 corresponds to what? 3 over 5. So it's greater than 3 over 5. Then the very last one, which is what? 1 over 3. So that is also greater than 1 over 3. So basically, this is how we do what? We change fractions to what? Be able to arrange them in order, either in ascending or descending order. This first method here would have to change all the fractions into their equivalent forms where they all have the same denominator. We do that by using the LCM of the denominators to evaluate. Let's look at another method. In our previous videos, we have treated how to change fractions into decimals. So in this one, I wouldn't go deep into it, but we would still apply it to solve the questions. If you really want to enter converting of fractions into decimals, then you can visit the previous video and then learn from it. So the decimal conversion method, on the other hand, for the decimal conversion method, what you do is you have to change all the fractions into what? Decimals. We change the fractions into decimals, then from there we do our comparison. So let's take some few examples to understand how that also works. We have to arrange these fractions in what? Descending order. So how is it going to be? So first of all, we take 3 over 4. So for 3 over 4, and then change it into what? Decimals. We do that using our long division. So as we did in our previous videos, 4 divides 3 how many times? That isn't going to work. So we have a 0 point, allowing us to bring 0 here. Now 4 divides 7 times. Then 4 times 7 gives us what? 28. If we subtract, we have remainder 2. And then our decimal point allows us to add another 0 to it. So 4 into 20, 5 times. 4, 5, we have a 20. And if we subtract this time around, we have nothing. So our 3.4 in decimal actually becomes what? 0.75. We'll go to our next fraction, which is 2 over 6. So for 2 over 6, also in decimal, what are we going to do? We have our decimal, our long division, and then 6 stays outside whilst 2 stays inside. If you have to divide 2 by 6, that isn't going to work. Hence, we are allowed to put 0 point. This decimal allows us to bring 0 here. 6 divides 20. How many times? We have 3. 6, 3, 18. If we subtract, we have a remainder of 2. We are allowed to add another 0 to it because of this decimal point. And the process starts again. 20 divided by 6, we have another 3. 6, 3, 18. If we subtract, what do we have? Another 2. And you realize that it goes on and on and on. So we can end that over here. All right. Then our last fraction, which is 1 over 5. So for 1 over 5, 1 inside and then 5 outside. 1 divided by 5 isn't going to happen. Hence, we have a 0 point, which allows us to bring a 0 here. 5 into 10 twice. So 5 to 10. If you have to subtract, we have nothing. So 1 over 5 also, on the other hand, gives us a decimal, which is what? 0.2. Whereas 2.6 give us what? 0.333. So if you have to compare these 3 fractions, how do we know which is the greatest? So you can see they all start with 0. Hence, they are all what? Less than 1. And since they are all less than 1, we go to the next digit. So this is 0.7. Take note. That is 0.7. But this here is 0.3. This here is 0.2. So just by comparing the first decimal place, you realize that what? The 0.7 here is the biggest. And it corresponds to what? 3 over 4. So it means 3 over 4 is our biggest fraction. Greater than. So we are now done with this over here. Then we come to the next one. 0.3 and 0.2. 0.3 and 0.2, which is bigger? 0.3 is certainly bigger. So followed by 2 over 6. Then the very last one here, which is what? 0.2. And 0.2 corresponds to what? 1 over 5. So simply put, to convert or arrange fractions in order using the decimal conversion method, all you need to do is to rewrite the fractions as what? Their decimal representations. After which you compare the digits. If you have that which have the same digits in the first place, so let's say 0.75 and then 0.72. As you can see, they have the first one being the same. So you go to the next one, which is 5 and 2. 5 and 2, which is bigger? This over here, 5 is bigger. Hence, this decimal representation is what? Bigger than this here. So basically, this is how we arrange fractions and then compare them as well. Our first method was what? The common denominator. And then this other one here is the decimal method, the decimal conversion method. So I'll write down some exercises you can always try on your own. Now, if this is your first time on this channel, this is Half Beyond Numbers, where we learn maths the easy way. If you would want to receive notifications whenever I upload educational videos, kindly subscribe. So these are some examples you can try on your own to test your understanding. As usual, if you have any challenge, you can just let me know at the comment section and I would try my best to address that. Thanks for watching to this end, and I hope the video was helpful. If it was, you can like and then subscribe as well. Stay safe. This is Happy Beyond